the last resistor that I have overlooked. It's a bit wobbly on here. Trying to get this. Hang on. Maybe my IC extraction tool can clamp onto something. I don't know. Oh, that's better. Right, that's soldered on. Okay, so I'm ready for a little test. I think I'll use this bubble wrap to put this on. This bubble bag, whatever. I don't want anything shorting out the connections. I've got it the wrong way round. Alright, I'm going to unplug this solder iron again. Right, let's see, power leads. I really have to put some subglue under these sockets because they twist. They twist when you tighten them up. I don't like that because it weakens the connections on the back of the board and causes the tracks to lift. This super glue is a container. It's getting a bit manky. Where's my acetone gone? Dries so freaking quick, this stuff does. I'm cleaning the neck of the ball because I'm going to put my focus, this little adapter thing on, and if this neck is a bit thick with that glue, it splits the flipping thing. It's happened to me before. This nylon thing just splits. And it doesn't seal properly as well, that's another problem. Right, I don't want to get it on my wires, I just want to get this socket glued to the board. And the other ones. this out as well. I've got that. Now my 60 volts output comes out of this socket here, so I want to monitor that as well. I think the last time I was using this, I might have got some glue on the connections, because I haven't glued it this time. It was already stuck. Well, it should be better now. That's better. And it's not twisting. The socket's not twisting now. I've super glued the plastic to the board, which is good. I'm not worried about the pulse output at this point. I want to check for noise and ripple and everything. So, right, let's see. Get my connections back on here. Okay, so I'm looking for 60 volts, or 57 volts anyway. I'm not sure if this 50 volt 1000 microfarad capacitor will be able to handle it though, but well, we'll see. If not, I'll just stick this other one back in. That's what I'm doing a test on. Obviously I'll know by current consumption, because the voltage tripler circuit will triple up the voltage across this capacitor. If this capacitor doesn't like the extra voltage, then I'll stick the other one back in. Right, that white is actually ground on this. Yeah. I haven't actually got any chips in yet, don't forget. So we're not going to see it. We're not going to see much yet. I'm testing. This is a load test. Let's see if there's any shorts anywhere. I'm also going to be connecting to my lamp instead of the actual full power input, because I just want to see if my lamp dims too much, and if it does, I know I've got an overload somewhere. So I'm going to be clipping onto my 12 volt LED lamp, and if the lamp goes really dim, I know I've got a short somewhere. Oh, it dipped and then it went back. It's fine, no shorts, no shorts. Right, so now the next step is to put my timer chip back in, which is here, and it's covered in dust. I'm going to drill in, disconnect. I'll just turn my lamp out, because that effectively turns the power off to this. I'll put my chip in. It's a bit fiddly actually. Right, timer voltage quadrupler tripler circuit is now should be effective when I turn it on. Test. Right, we should see voltage on here now. Oh, I'm still on the K range. Oops, I could have blown my meter then. I'm not seeing any voltage coming out. Oh, you know why? Because it needs more voltage. I hope I'm below my meter. Let me just unplug it and check. Because I was on the flipping resistance range. Duh! I don't normally do things like that, but... I'll check a resistor. Make sure everything's good there. I'm on the... Let's go back to resistance. Right, 300 ohm. That's right. My meter's still okay. Ah, that's really voltage. Let's check voltage input. Right, 11.61 volts going in. That's okay. That's the voltage that I've got going into the board. It needs more than that to run. That's correct. So I'll put this back on. It won't work properly until I actually put the proper voltage in, because it needs 15 volts to run properly, and that's by design. I don't want it doing anything until the voltage is right, because it wouldn't work properly anyway. Now, question is, right, so I'm going to get my other voltage leads clipped on now, so I'll take these off. The point is, I'm not seeing any overloads or anything somewhere, so that's all good. I just realised I left that other power supply turned on all night and I didn't realise, but never mind. This is ground. Now, ooh! What the heck? I can hear it singing. Oh, the microphone is picking up the noise. That's interesting. Just a minute. Over limit? What? This is not possible. I am seeing 1000 something volts on my meter. This can't be right. I am using a low ESR capacitor though. Just a minute. Well, that's strange. Oops. It's actually how have I got all this connected right? Right, I'm gonna get my other meter. I don't know what's going on here. There's something very odd going on here. I'm not seeing any current draw, hardly. Is anything getting hot? No. Right, let me check this on the other meter. It says over limit. Right. going to my white meter, I've not got no output. That's very odd. Let me just check this a minute. Right, I need to put this on input voltage. Oh, this meter's acting up. It's not working properly. This white meter is not reading properly. I don't know what's going on with it. I've had some problems with this white meter the last few days. I think it wants a new capacitor in it. The oscillator's not working right. Check it on ohms. Right. Well, that doesn't add up. Let's check this voltage input again. Oops, got a flipping it. Hold on a minute, I'll just move it out of the way a minute. Ground positive. What? Oh, that's right. 20 volts input. That's correct. Volts in. That is correct. I am not seeing anything coming out. So what the hell is going on with this? Oh. I have to get my scope on it. Let's check the oscillator. Might be too high or too low. Well, the oscillator's working. I haven't got any output, and it's not drawing any current. Now, I haven't changed anything, so possible that I've got a wire break somewhere. See, always something new happens when you do things. 1, 2, 3, that's the output. That should be going to that resistor. That's in the diode. The first time I've heard it sing like that, so I wonder if it has something to do with my choke. Don't forget I haven't got the second chip in, I'm just testing the voltage quadrupler right now. Take this off in a minute. The driver chip for the trigger output circuit is not plugged in right now. I'm just sorting out the voltage tripler circuit. So yeah, what the heck is wrong here? I've got another diode in. I haven't got my capacitor across these outputs here. It shouldn't need them. It shouldn't need that. That's a snubber capacitor. It should still be quadruple, tripling. I must have got a short, but it's not drawing any current, so I think I have a short somewhere. Oh, that flipping power leak on the floor again. I hate these flipping Chinese leads, they're just horrible. They're slimy. What I mean is the plastic is on them leads is so slimy that when you squeeze them, the flipping plug inside twists around inside and you can't squeeze them because they keep twisting around like that. You know, these ones aren't so bad, it's the other ones. Well, the thing is, it's not drawing any current. So there's no shorts anywhere. It's not tripling the voltage, so it's like there's an open circuit or something. Let's see if there's any voltages in any of these capacitors. There's 1 volt in that one. That one's at 0 volt. Ooh, what? It's 39 volts across this capacitor here, right? $39 volts across this capacitor right here. 37 actually. Let me put the black meter back on a minute, because it's a bit smaller. I don't think I damaged it, I think it's fine, shouldn't have done. I want to compare it. Right, I don't know if you're able to see it, but I'll move this over here a bit and right, where was I? 39 volts. It's not plugged in right now, remember it? It says 36. So we have 36 volts across. I'm just going to move this over here. I'm trying to look at this over my shoulder so you can see it on the film, the camera. Right, 36 volts is on that capacitor. It's dropping actually because I'm discharging it through my probe. Now the next one, what's that, 31? 31 across that one, so it's working. 31 across that one. The next one is 72. Wow, 71 volts. Oh my god, I've never seen voltages that high before. There's no wonder I was getting an over limit thing. Blooming heck, 71 volts. I've never had I was getting 57 volts before, and I'm seeing there's 71 volts across this capacitor here. It's dropping 67. Wow. So why I hadn't seen any on the output? Hang on. These capacitors are rated at 100 volts, right? Why am I not seeing any output on there? Oh, let's check this big one. The big one that's 1000 microfarad. What's on there? Nothing. Oh, duh! Do you know what? You're not going to believe this. I forgot to put a wire link in here. Oops. Yeah, there's a wire link in here, and I forgot to put it in. Duh. There's no wonder I'm not getting any output. Right, hang on. I suppose I better discharge those capacitors. Put it on 200 milliamp. To go discharge these capacitors so I don't get electrocuted. Oh, well, it's 71 volts. It's not. Oh, ah. Right, I discharged that capacitor. Yeah, it's working. Discharge them all. Right. Okay, they're all discharged now. Right, I've got to solder a wire link in. Right, I've got some bits of wire cut up on resistor legs lying around. I usually have. Oh, I put them all in the ashtray, didn't I? Threw them all away. Oh well, I'll find a piece of wire. It was singing. I have never not heard it sing like that before. Ah, there's a bit of wire here. I think that's too short. I'm just going to get it off here. The reason why I like resistor legs is because they're nice and straight. This is all crinkled. I wonder if I can see any in here. Yes, I can. I'm going to nick one of these wire links off the resistors out of my bin because it's covered in gunk. Hang on, where's my tissue? I like these resistor legs that you cut off because they're nice and straight and they're tinned. It's a bit. Oh, it looks like it's got solder on it. I had another one. I stuck them all in my bin and now I can't see them. You don't want to look in here really. Oh, I found another one. That's perfect. Right. Yeah, it's jumper leads is a problem. They're so easy to overlook. So, can I get to the jumper link? Right, I can see it. Yep, right, I'll bend that in and solder that in. Okay, I should have put my iron on. Oh. Now I've got to whip the frigging thing. I was surprised to see 70 volts. I'm glad really if it's working better than before. Well, it might be because there was no loading capacitor on the output. The loading capacitor, oh sorry, the storage capacitor, they always have a drop, a resistance across them. You know, the electrolytics are very leaky. And the higher the capacitance, the more leaky they are. So I'm not expecting to see 70 volts across this 1000 microfarad. It's rated at 50 volts, so it'll probably, the resistance will probably pull it down to 50 volts maximum anyway. If it goes over 50 volts and it's like 60 or something, I'll be a little bit concerned. So I might put the 63 volt one back in again, because I don't want to blow my capacitor. But anyway, like I said before, you need quite a lot of current actually, consistent current, you know, as in constant current I should say, to actually blow one of these up, and there's not enough current really in this circuit, because it would trip my polyfuse if it went over 600 milliamps, so it wouldn't blow the capacitor, it would just trip the polyfuse. So I'm not worried about the capacitor blowing up, because that won't happen. But as I say, I've been trying, I said in the previous video, I was trying to find a high frequency gain, this is what this capacitor is, of 1000 microfarad at 100 volts, and the only ones I could see on eBay were like £4 something each. And I thought, well, I'm not spending £4 just for one of those. I'm still looking actually. I'll have a look online, see if I can find some somewhere else. But if I can get away with this one for now, but it's for testing anyway, so it's not critical. But obviously, if it was a permanent build, I would have to use the right capacitor voltage, because yeah, you can't just, this is all experimental. Another way of doing it is to use two of these in series, two 1000 microfarad or two 2000 microfarads in series. But then to get, well, two in series will be 1000 microfarads, but it'll be higher voltage. But the problem with that is more board space, and I haven't got the space, as you can see, that is heavily populated. The only other way is to get a bigger board, build it on a slightly bigger board, and that means moving everything and, well, expanding this end at least. So this section will be expanded even more. I could do it. But yeah, I'm trying to keep this to a smallish size. Right, I should be ready for soldering now, hopefully. Right, where's my link? There it is. Right, that's in. Hopefully I haven't forgotten anything else. Now, check it for solder bridging. It looks okay. Oh, hang on, there's no link somewhere here. Ha! I missed an O-link out. What's the matter with me? What is the matter with me? I just discovered another link missing. Yeah, I'm just going to have to take some wire off this red wire, I think. I'm going to measure it on this side and then put it in on the other side because I want to get the distance right. I suppose that's because I went to bed yesterday after I was totally shot and tired, and I assumed I'd put the links in and I hadn't. Right, that's in. I'm glad I spotted it as well. I didn't want to be doing this again, like 10 minutes or an hour later, figure out that there's another link missing. Right, well, literally, you won't believe it. I mean, there's literally only 3 links on this board. I got it really dense, and normally I try to have a target of no links, but sometimes you just can't avoid them. That's why people go for double-sided board usually, but I don't like double-sided board. Right, so any more links? I'll check the solder bridging. Nope, no solder bridging on that one because it's very far apart. I don't like this flipping wire that I'm using because it's got a hump in it. Never mind, it's like clipping my probe onto, I suppose. Okay, yeah, there's only 3 links. I can see all 3 of them. I've got them all now. Right. Turn my iron off because I just want to save energy and don't want to have an accident with it. Right, let's do this test again. I was worried that I'd damaged my meter, right? Well, there's no way because there's no power there. Thank God. I'm getting very absent-minded these days. Okay. I need to power lead back on here. Ground. Positive briefly. Oh, I saw my current surge. Oh, look at this. 57 volts. Yeah, that's good. I think that capacitor can take it. Is it dropping? It's going up. So the capacitor is able to handle that by the looks of it. Oh, it's actually getting higher than it did previously. That is amazing. It's actually at 60 volts now. 61. Still going up. This circuit is working great, and notice it's not singing anymore. 63, 64. Holy moly! 67, 69, 70. Wow! I've not seen it go that high before. My circuit board design is a lot better than it was. It's not, bloody hell, it's nearly 80 volts. It's at 80 volts. 85. Still going up. How high is this going to go? 90. I don't want to blow this capacitor. Please don't blow up on me. What? 100 volts? Are you kidding me? It's going back down again. Now what the heck? Have I connected properly? This is crazy. It's telling me there's 123 volts across this. I don't believe it. No, this is stray. Something stray going on here. When I touch this capacitor, it just drops. Is this grounded properly? Let me just connect to another ground. Directly to the main ground. Don't get on it. What? No, that's not possible. That is not possible. That is impossible. There can't be. I can't have 160. No, there's something seriously not right here. That is impossible. Let me take this thing off and measure this capacitor directly. I don't want to short anything out. Let me just directly measure this capacitor and see what's going on here, because that's not right. What? What? I'm on the 800 volt range. It says over limit. That is not possible. Right, power lead's come off now. That's a good thing, because I was going to disconnect it anyway. There's something wrong. There's something seriously, mysteriously going on here. Right, it's according to this, I'm at 64 volts, right, which is what I expect. I think what I'm seeing is some kind of resonance or RF. I'm seeing some kind of RF. I need to get my scope on it. Right, let's get this ground lead back on here. There's some RF. Let's just charge it again and then disconnect it and see what happens. This flipping Chinese lead, look, I squeeze it and it twists around on my fingers. Right, look at that, there's RF, that's what it is. Right, disconnect it, it's giving me 63 volts, so that's what I expect. So what's happening is once this capacitor is charged up fully, there is RF being generated which is giving me false readings. So that is the actual voltage, 63 volts. And when I connect this power again, it just goes crazy. This is RF somewhere. And let me get my coil a minute. I'm going to discharge my coil across this thing. Right, you're watching the gauge. Right, discharged it. Blue tack on. That is a lot stronger than it was before with that. That is good. A nice good pulse there. That was a manual pulse, obviously. Right, so if I connect this again, because it's under load, I can't even trust what I'm seeing actually. All I can trust is the current consumption. This charges up really fast. Let's just discharge this again. I'll turn it the other way. Right. That's good. Strong. Okay, let me check, see how fast this charges up when I put this on. About 1 second. So yeah, right. I need to put my scope on this and see what's going on. I'm hoping I haven't got RF. I hope my choke's wired the right way around. It's supposed to snub interference, and I need to check the power supply rail to that chip before I actually can put the chip in. The other chip, you know, for the pulse output. I want to make sure that there's no RF on the supply lines. So my stream's going to restart in a minute, so I'm going to stop it manually and save it, and then I'm going to come back in a little while, and hopefully I'll have my scope online, and I'll try and record what I'm seeing on there as well.